Hello, my name's Matthew Yee King, and I'm going to talk to you about my research paper, which is all about understanding student coding behaviours in our creative computing lessons. So I just want to acknowledge that this paper has been developed with colleagues at Goldsmiths and the University of the Arts London, and it was partly funded by AHRC and EU funding of various other sources. Okay, so the summary is that I'm going to, first of all, introduce my research questions. Then I want to talk about the context of the research. So what do I mean by creative computing? I'll talk about the tools we've used to gather our data, the data set we've gathered, how we've analysed it and what we found. And finally, we'll conclude by revisiting those research questions. And also I'll do a plug at the end, hopefully, for our new project. Okay, what are the research questions? So there's three. So number one is, how can we characterize student coding behaviors? So the motivation there is we don't know what students are actually typing into their text editors in our programs, because we just see the end result of that, which is what they submit at the end. We don't know what the process is that they went through to get there. So we really want to unveil that process and understand it better. Secondly, what do students do with our demonstrator code? So in our lessons, often we present students with example code, and then they have to work on that and develop it and make changes to it. And we really want to know which demonstrator code maybe induces or makes certain types of behaviours more feasible. So is it a good starting point for developing their own programs, or is it a good demonstrator of a concept? Things like that. So we're really interested in whether our code that we're providing students with is being used and how it's being used. And finally, how do coding behaviours vary in different contexts? So once we've characterised the coding behaviours and we know what they're doing with our demonstrator code, how does it vary depending on the instructor or the style of lesson or the context, things like that. Okay. So what is creative computing? So briefly, creative computing is not just about students creating programs that make graphics or sound, but it's also much more actually about the process. So what is the process they go through? Because we think that in terms of art school pedagogy, it's all about the process. It's very much how do they look at their work, how do they critique their work, how do they explore the space of problems and build their own understanding. So it's really that kind of inductive learning approach that we're interested in with creative computing. And yes, they do graphics and sound often as well, because we find that is generally a nice exploratory area for students to work in. Okay, I just want to demonstrate the tools now. So I'm going to show you the Code Circle platform. So all of this stuff we're going to present today was done in the Code Circle platform, all of the programs we're analysing. So I'll show you the Code Circle platform now. Okay, right, so here it is. So it's a browser-based coding environment. And you can see on the right panel here, I've got my code. And then in the left hand side there, you can see there's my program that's currently running. And so that's actually a shader program running in the browser. So it's also a live coding environment. So I'll just show you what happens if I start editing the code. So you can see it's kind of re-executing the code. You can see that the graphics are becoming a bit thicker as I change that variable up. So let's make them really super thin. There we go. So now we get a nice tendril. So that's the basic idea. So that's the first thing. It's a live coding environment. You can hack your code and see what happens straight away over there in the graphics display. It also obviously works with sound. It's all browser-based language technology. Now the second thing I want to show you is that it's very easy to share programs with students. So let's say I've got I want to share this program with students. I can quickly go in and add a tag. So let's say ITICSE, okay? And now what I can do is I can tell my students, go to Code Circle and search for the tag ITICSE, and then straight away they'll get my program and they can jump in there. And that allows me to show you the final feature, which is that Code Circle makes it very easy to make copies of people's code. So you can go in there, press that fork button, and then you get your own version of the code. And often we will present students with an example program and ask them to fork it, find it, fork it, and then do their own version of it. Okay, so that's a kind of key feature of the environment. Okay, so that's Code Circle. Let's jump back to the slides now. And so as students are using Code Circle, it generates a sequence of operations. So it's been designed to be a collaborative coding environment so that they can do a kind of Google Docs style editing the same document at the same time process. And and what it does is it generates these operations here. So you can see an example of that data there. So every time they put some code in, it stores which change they made, where in the program they made that change. And this allows us to reconstruct the programs afterwards, so we can see exactly the stages they went through, how the program changed over time. Now the other thing is with the data, I showed you that forking feature. So with this fork feature, we can recreate the fork tree. So say B at the top of that diagram might be my example program, and then C and D are two student programs, and then maybe the student then further forked it themselves, made multiple versions of it. So what we can do is we can examine the whole behavior that happens after you create the program from the whole fork tree. So not just your version, but what other people do with your program as well. Okay, so we're working with a data set of 16,245 programs. So these were gathered in a variety of contexts. So we've got summer schools, we have on-campus teaching, and also online teaching in massive open online courses with thousands of people in. So yeah, lots of people have used the environment in different contexts. So what do we do to analyze it? Well, so first of all, we came up with a set of metrics which allow us to analyze the data, and these metrics are detailed in the paper, but essentially it's all about looking at how the program changes over time and what other people do with the program. And we used abstract syntax trees to look at the semantic structure of the program, the functional structure of the program, and examine how much that's changing. How much did it change? How rapidly did it change? What kind of operations were they doing? Were they inserting code? Were they deleting code? Were they exploring a space? So this really is how we characterize the student coding behavior. So the process is we took 16,245 programs and we extracted, those metrics for every document, and then we calculated those as averages over the fork tree. So we can say, for this starter program, we basically can see exactly what happened to all instances of that program over the fork tree, and that allows us to characterize the patterns of behavior on important programs. So we define important programs as this 304 programs on the system which had 5 or more forks by people other than the original creator. So these are kind of programs that other people are using. Okay, the results. So first of all, we did a k-means clustering. So we found that K4 was the ideal number. So the idea is that you got 4 clusters, and that gave us the best balance of cluster size and overlapping. So that's what you can see there. Okay, nothing particularly exciting there. But then what do those clusters look like in terms of our metrics? Well, you can see that I've got the metrics around the edge of the diagram there. So we can see that each color is a different cluster. So we can see that the green cluster, for example, had high levels of vocabulary reuse, which is where students are taking the example function calls that are in the starter program and reusing them. And it's got high levels of AST change rate, so you can see they're making lots of edits on the AST, rapid edits to the syntax and structure of the program. And then other clusters are characterized in different ways. They're much more about sort of high exploration. So you can see that purple cluster there has high insert to delete ratio, which means there's lots of deletes going on relative to insert. So students are putting code in, they're taking it back out, they're putting code in. So as you saw earlier when I was working on the code circle environment, that I did that too. So how do we characterize each of the clusters? Do these kind of, and this shows that there's very specific features of each cluster which allow us to characterize them in terms of, yes, this set of programs were used in a certain way, this set of programs were used in another way. And we also found that the instructor that was responsible for those original programs actually was identifiable often in the cluster. So cluster 1, many items in that one from the same instructor. So that instructor's teaching style and demo program style obviously seem to lead to very similar kind of patterns of use of their programs. And then cluster 2 had a different instructor mostly, and they had a different pattern of coding style that happened as a result of that teaching. So you can see the context is really affecting what happens. And then we found another one cluster had lots of student programs in that other people were reusing. So that had so obviously the way that people reuse other students' programs is different, because that probably happens outside of a lesson maybe, or it's different. So it really gives us some insight into how the patterns of behaviour vary with context. Okay, so let's revisit those research questions. I'm just about out of time, so I'm going to very quickly cover these. So how can we characterise student coding behaviours? So we've shown that we can characterise them by coming up with a bunch of metrics which describe what they do with the code, and that our platform allows us to capture those metrics. We have shown that we can look at what students do with our demonstrator code. So depending on the instructor and the context, different sort of patterns of behaviour happen. And finally, how do coding behaviours vary in different contexts? So as I say, different instructors, different teaching styles, different styles of demonstrator program lead to different types of behaviours. Okay, so finally, I want to do a plug. So go to mimicproject.com. That's our new coding platform. It's like the version 3 of this coding environment. So Code Circle's version 2. This is version 3, and it's all about helping musicians to access machine learning technology through the browser. So there's loads of cool examples on there. And this project is a collaboration between Goldsmiths, Durham, University of Sussex, University Arts London. Google's a bit involved in that as well with the Magenta people, so hopefully, and it's funded by the AHRC in the UK, so go and check it out. I'm sure you'll find lots of fun stuff on there. So thanks very much for listening to my talk, and I hope you enjoyed it, and I'm going to try and check out if there's any questions afterwards.